Look at this relentless digital downpour. Every single minute, over 500 hours of new video crash into YouTube servers. To put that volume into perspective, if you tried to sit down and watch just one single day's worth of those uploads, the runtime would outlast an average human lifespan. It is roughly 80 years of continuous footage arriving every 24 hours. We casually refer to this process as uploading to the cloud, as if our media floats in some weightless, ethereal space. But the cloud is a physical place. Every single pixel uploaded requires real, tangible hardware. After processing, a single hour of uploads demands 1 petabyte of storage, occupying a modern, high-density server rack. In 30 days, this growth requires 360 new racks. Packing machines generates 5 to 7 megawatts of heat, requiring powerful cooling systems to pump chilled water. Managing this platform requires winning the constant race against physics, building new physical infrastructure fast enough to keep the weight of incoming footage from crushing the system. The moment a creator clicks publish, their file doesn't just sit idle on a hard drive. It enters an immediate, brutal transcoding pipeline. The system rips the raw video apart, compressing and re-encoding it into dozens of different formats. It generates everything from a tiny 144p file designed for a weak 3G mobile signal all the way up to a massive high bitrate version for a 4K television. Watch how this animation breaks down the raw file. Once fragmented, it immediately duplicates. These copies are distributed across global facilities, ensuring an outage in California won't stop a viewer in Ireland. These fragments are housed inside the distributed file system, Colossus. But storing the raw footage is only part of the equation. A massive file buried in a server is completely undiscoverable without its lightweight metadata, such as the title, the video tags, the view counts, and the user comments. By permanently separating the heavy video chunks from their lightweight metadata, specific databases like Vitesse and Bigtable can organize, search, and retrieve information instantly without having to physically move the massive media files themselves. Storing all this data flawlessly solves the archive problem. But if a video takes 10 seconds to buffer for a user on the other side of the planet, the system has failed. Latency is the real enemy. To move data globally, the network relies on physical arteries like the ones depicted here. Alphabet co-owns over 100,000 miles of undersea fiber optic cable, pulsing with lasers that transmit data as light across the ocean floor. Those lasers travel at the speed of light, but distance still matters. Fetching a massive 4K file from a central server in California every single time a user in Tokyo clicks play is highly inefficient. To eliminate that latency, engineers built the Google Global Cache. Instead of forcing the user to retrieve the video from across an ocean, the cache brings the content directly to the viewer's neighborhood. Google ships caching servers to local internet service provider hubs, establishing over 3,000 edge locations worldwide. When requested, that local node feeds the user 1 to 5 second adaptive chunks. These packets seamlessly grow or shrink in beta size depending on real-time internet speed. When a viewer watches a viral hit, it plays instantly precisely because those fragmented video chunks were already pre-positioned on a rack sitting just a few miles from their house. Delivering footage perfectly creates a new problem: the paradox of infinite choice. An ocean of flawless, buffer-free video is useless if a viewer cannot decide what to actually watch. To filter the noise, the platform utilizes a highly specialized two-stage deep neural network recommendation system. Stage 1. Candidate generation. The system uses your watch history to collapse billions of videos into a focused cluster of relevant choices. Stage 2. Ranking. A secondary network scans these candidates, assigning precise scores, organizing a final list in milliseconds. This rapid two-tier algorithmic curation transforms an overwhelming archive of exabytes into a single, highly engaging, personalized homepage. The simple act of tapping a thumbnail on a screen instantly triggers an impossibly vast planetary-scale apparatus. Maintaining this automation requires immense human capital. Behind the algorithms sits a global army of elite software engineers, data scientists, and security analysts, working around the clock to keep the network online. As you can see from this digital monolith, the sheer accumulation of data is staggering. Current estimates place the total size of the stored video archive between 10 and 15 exabytes. To grasp that volume, If you stored 15 exabytes on standard 1 terabyte hard drives and stacked them vertically, the resulting tower would reach higher than the International Space Station. And the scale never stops expanding. In the short time it took to watch this video, another 4,000 hours of fresh footage have already been ingested, processed, and distributed globally. This massive global infrastructure functions today as the most heavily engineered, continuously expanding physical machine in human history.